All right, so first function that I want to look at, x to the fifth minus 5x. Let's go ahead and notice that we can factor this as x to the fourth minus 5. And actually, this is a difference of squares, so I can split this as x squared minus root 5, x squared plus root 5. This part doesn't factor, it doesn't have any zeros. This part you can actually split even more. If you want to solve this equals to 0, then you're going to get x squared equals root 5. So x is plus or minus the square root of a square root is the same as the fourth root of 5. And by the way, yeah, we'll jot that down in a minute, but I just want to point that out to you. That's where that's coming from. What else can we say? Well, first off, let's notice this is a odd degree polynomial, and so you either can know that way or actually compute the limit as x goes to infinity of f of x. You can factor, actually look right here, this is going to go to infinity, this goes to infinity, and so this thing is blowing up to infinity. The limit as x goes to minus infinity of f of x, you can look right here. This part goes to positive infinity because the fourth kills the negative. This part goes to minus infinity. So this guy is minus infinity. That's good to know. So we've got the end behavior. It's also worth noting, I'm not going to actually check it and prove it, but you could check at a glance. F of x is an odd function, so there's going to be symmetry around the origin. That's nice to know that. You could get by without knowing that, but it's nice to know that if I don't see symmetry, then something is wrong. The y-intercept, you just plug in 0. F is defined at 0, so the y-intercept is just 0, 0. I should have mentioned that at the beginning. This is a polynomial, so its domain is everything too, by the way. And then the x-intercepts, well, we've already got one of them. One of them is at x equals 0. That's the same as the y-intercept, right? And then over here, we found the other two, and we got x is plus or minus the fourth root of 5, which is roughly 1.495. So I'll need those to be able to graph this. So notice all of this information is just things you could have figured out from, without calculus. You could have known the end behavior here without writing it in terms of limits, although that's what you're actually doing. So now we'll use our tools from calculus. Let's go ahead and compute f prime. So f prime is pretty straightforward. 5x to the fourth minus 5. Pop a 5 out, 5x to the fourth minus 1. This is 5, x squared minus 1, x squared plus 1. So 5x minus 1, x plus 1, x squared plus 1. This quadratic, the sum of two squares, doesn't split. You can't factor it. It's never 0. So the only two zeros are x equals 1 and x equals minus 1. So now I'm going to make a number line, and I'm going to go ahead and label that number line f prime. I'll list my zeros of f prime, minus 1 and 1. I'm going to plug in points, and actually it's not hard to just see. I'm just going to jump right to it. When you fill it out, you get that. You should pause the video and check that if you have any doubts about that or struggle with that at all. And now I can conclude a bunch of stuff. So I know that f is increasing on minus infinity to minus 1 and 1 to infinity. I know that f is decreasing on minus 1 to minus 1. I know that f has a local max there and a local min there. Let's write that down. So there's a local max of what? F of negative 1 equals 4. I'm plugging into the original function, which is not listed on the screen, but you've got it. There it is, x to the fifth minus 5x. And then I have a local min of f of 1 equals minus 4. And because of symmetry, I'm not at all surprised by this, right? Once I know that this is a local max, then I know that has to be a local min, just from the fact that f is odd. But again, you don't have to know that. It's just nice to know that. All right, so now I'll take a look at the second derivative. I've already computed it, just 20x cubed. when you solve this guy equal to 0, you just get x equals 0. So 0 on this side you're positive, on that side you're negative. Plug in 10 into 20x cubed, you're positive. Plug in a negative, you're negative. And so we can say that f is concave up on 0 to infinity. We're concave down on minus infinity to 0. And f has an inflection point at x equals 0. Well, we know that x equals 0. When I plug it in, I get out 0. And so this is just the point of inflection. The actual point is 0, 0. So at this point in the game, you're ready to put it all together and sketch a graph of this guy. So let's draw our picture. I like this color. Let's draw our graph in that red. So I know that 0 is a point on my graph. I also know that if I scroll up, we found that the fourth root of 5 was roughly 1.5. So I marked those on here. And when you plug in the positive fourth root of 5, you're down here at negative 4. So we can put kind of a steep little local min there. And then when I plug this one in, I'm going to be up here at positive 4, and I'm going to have, let's see, something like that is going to be steep. And then I've got my, wait, I'm sorry. I'm plugging in, hold on. I was plugging in the wrong points. Let's start over here. I've got 0, 0. I'm plugging in 1 and negative 1. I was mixing them up. These are actually the fourth root of 5 minus fourth root of 5. Those are the x-intercepts. And then when I plug in 1, I'm down here at negative 4, and I'm going to have to be pretty steep. And when I plug in negative 1, I'm up here at 4, and I'm going to be pretty steep little curve. And actually, I know that I'm shooting off to infinity on this side and then minus infinity on that side from my limits. And so I'm ready now to try and sketch the graph. And you just want to go through all the points. It's hard to get a nice sketch on this iPad. My pencil is slipping. It's not at all very nice. Whoa, I overshot. Let's try again. So it's not, I don't like that either. It shouldn't curve out. It's just very steep. Yeah, I'm struggling to get a straight line here. It just is, my tip of my pencil is slipping. We're going to come around, and then we're going to shoot down, and whoa. That's pretty awful, actually, but it's the best I can do. I don't have a lot of time to keep making this new. I will erase this part, I guess, because I kind of wobbled there. It should sort of just go straight like that. That's better. There we go. Okay, so that's a rough graph. Now, what you should do is go through and check concavity, for example. You know that you should be concave up on this side, and you are. Just draw some tangent lines. The function is above the tangent lines. Inflection point, that looks very much like an inflection point because you're clearly concave down on this side, drawing tangent lines. So we've got that taken out. We've got you can see the increasing, decreasing, increasing matches like what we said. We've got all the features of the graph, and so that